and welcome to today's physics class. In today's class, we are still going to solve more problems on vector. Now look at this question. Question says, a boy pulls a nail from the wall with a string tied to the nail. The string is inclined at an angle 60 degrees to the wall. If the tension in the string is 4 Newton, what is the effective force used in pulling the nail? This question is actually from SSCE November 1989. So before we can be able to calculate this force, we need to get the vectorial diagram. And that is where many students are finding very difficult. For you to illustrate a vector question with diagram, it takes what? Analytical reasoning. Now let us look at the wall. Let's assume the wall is like this. Okay, let's assume this is the wall. Okay, let's assume this is the wall. And the nail is there. Let's assume this is the nail. And this nail is to be pulled out. A string is tied to it. And we are told that the string is inclined at an angle 60 degrees. So let's assume this is the wall. Okay, this is the wall now. All right, this is the wall. And the string is inclined at what? Angle 60 degrees with the wall. This is what? 60 degrees. So this is the string. And we said that what the tension in that string is 4 Newton. So now the effective force which is required to pull this nail will be this horizontal component here. This is the effective force. This is where the force will go. Okay. So from here we have been able to form a right angle triangle here. So for us to get this force that we pull out this nail, it will be the horizontal component of this tension here, because this is the string that is tied on the head of the nail, pulling it out. So the force will be this angle, will be this effective force, which is the horizontal component. How do we get that horizontal component? If you notice here, this one here is facing this way. If we decide to bring out that triangle, this is how the right angle triangle. Okay, let's put it here. This is how it will look like. This is where it's going. Okay. All right. And the horizontal component is supposed to be here. Okay. Then, or this side, which is this side here, is also equal to this, according to the parallelogram law. So, which means here is the opposite. So, for us to get this now, this is hypotenuse. This is your 4 Newton. And this is your 60 degree. We want to get here now. This is effective force now. It's also equal to this. Okay? That is your F. And this is your F also, as usual. If you decide to join the parallelogram together. So which means sine 60 degrees or sine theta opposite over what? Hypotenuse. And this is our opposite here. Which means we're having sine 60 degrees equal to F over what? 4 Newton. So for us to get our F, your F now is now equal to what? 4 sine 60 degree. Now let us use our special angle to get our F. Sine 60 degree in our special angle is root 3 over 2. So your F now becomes 4 times the root of 3 all over 2. So this one cancel this out, have 2. So your F is equal to 2 root 3 Newton. So if you wish, you can use your calculator to have the root and multiply by 2, you get the answer in decimal form. So this is the effective force that is required to pull the nail. So let me tell you, do not come and use cos 60, because the angle here is either you use cos 60, is either you use a sine 60, or you subtract this one from 60, from 90 rather. Subtract this from 90, you have here as 30. Then if you use cos 30 degrees, cos 30 degree will work, okay? So you can say F is also equal to what? 4 cos 30 degree. And cos 30 degree and sine 60 degree are the same, which is 4 times root 3 over 2. So the same thing, it will give us 2 root 3. So it's either you use cos 60, or either use cos 30 or sine 60 to give you the right answer. So this is the end of today's class. If you find this class interesting, please help us to share this post and do well to like, comment. Also subscribe to my YouTube channel, Physics and Mathematics Lovers. Bye.